This lesson is on sine and cosine graphs, but it is also on period changes and horizontal shifts with those graphs. You should have gotten the basic information in the first video. So this time we're going to focus on these other two changes. The first thing that we're going to look at is period changes, and again, period is how long it takes to make one cycle of the graph. And so how you know that there has been a period change is when there is a number in front of the theta in the sine or cosine equation. So this k represents a number. So it might be sine of 5 theta, sine of 3 theta, something like that. You'll know that there has been a period change. So how do you know what that change is? Your new period, and you need this formula, so you may want to write it down, circle it, something. Your new formula, the period is going to equal 2 pi over that k. So 2 pi because that's the normal period for sine and cosine, and then you're dividing it by that number in front of theta. So depending on what that number is, you could have a smaller or larger period for your graph. Okay, for our first example, we are going to sketch y equals sine of 2 theta. And so again, I can tell that there's a period change because of this 2, and my new period is going to be 2 pi over 2, which the 2's will obviously cancel, so my new period is pi. So instead of going from 0 to 2 pi, I am now going to go from 0 to pi. And I still need to label 4 important points past 0 to get the shape of this graph correct. I have not got an amplitude change on this one, so I'm still going to go to 1 and -1 for that sine graph. This is the way I figure it out. If the end is pi, halfway between 0 and pi would be pi over 2. And then this mark is halfway between those two. Half of pi over 2 is pi over 4. And then you can count by that unit. So this is pi over 4, this is 1/4, then you have 2/4, the next one will be 3/4, so 3 pi over 4, and get those labels correct. Then you can come in and plot out your sine graph with a hill and then a valley, and connect those points. I would encourage you to graph y equals sine 2 theta and y equals sine theta at the same time, or sine x, excuse me, in your calculator so that you can see that period change and how it's different, because your regular sine is going to 2 pi, and what we just did, the sine of 2 theta, goes to pi, so it does the whole graph in half of the length it takes to do normally, okay, because this one will go just to pi. And it's hard to see when we're sketching it because they all tend to look the same. The labels are just different, but you have to remember that the labels mean something, and they mean that this is going on over here. The original was going to 2 pi, now we're going to pi, but we get the same cycle, a full cycle in that amount of time. So please understand what's going on, even though they look similar to what we did before. Okay, for the next one, we're going to do a cosine graph, and we're going to use 1/3 theta. And so the 1/3 is our k, and our new period will be 2 pi over 1/3. And when you're dividing by a fraction, you have to flip and multiply. So I really have 2 pi times 3 over 1, which is 6 pi. So this one is actually going to be stretched out. The end of the line for it is 6 pi. I need my important points. Halfway between 0 and 6 pi would be 3 pi. Halfway between 0 and 3 pi would be 3 pi over 2. And then I'm counting by 3 pi over 2. So 3 pi over 2, 6 pi over 2, 9 pi over 2. And that will give me my other points. Again, I'm not doing an amplitude change here, I'm just practicing. So 1 to -1 will be my same amplitude. And then this is a cosine graph, so it's a hill, and then a valley, and then another hill. So try to sketch that to the best of your ability. Now I want you to think about what has happened here. This graph is going all the way to 6 pi. So 6 pi way out here. So 2 pi would be back here. So normally your cosine graph does this, and for the one that we're doing right now, it's doing this. Okay, and this is not perfect. It's probably a good idea to try it in your calculator and see what the regular cosine graph does at the same time as this 1/3, and you can see the change. For our next example, we're going to add in an amplitude change. So we are going to add that amplitude of 2, which we discussed in the previous lesson, and then I'm also going to have a period change because I have this 1/2. So 2 pi over 1/2, if I flip and multiply, I'm going to get 4 pi. So I'm going to go ahead and label the end 4 pi. I'm going to put my halfway mark, my quarter mark, and my third quarter mark, and then decide what those are. So halfway between 0 and 4 pi would be 2 pi. Halfway between 0 and 2 pi would be 1 pi. And then this obviously would be 3 pi. Now with the amplitude of 2, that means that we're going up to 2 and down to -2 instead of just 1 and -1. And then finally, the shape of our graph is the sine graph, so it's the full hill and full valley. So I need to start on the midline, make sure I make it to that 2 and down to that -2 before I connect. And here is that graph. Okay, let's do another one with some changes. So for our fourth example, I have a -1/2. That means that our amplitude is 1/2, because remember the negative tells us something different. Amplitude is the absolute value of this number. The negative tells us that there is a vertical flip, and then I have cosine of 4x. So the period is going to change, 2 pi over 4. So our period is going to be pi over 2. So the end of our line is now pi over 2. And I need halfway, quarter, and third quarter. So halfway between 0 and pi over 2 is pi over 4. And then what is halfway between 0 and pi over 4? That would be pi over 8. It means I'm counting by pi over 8. So 1/8, 2/8, 3/8. Our amplitude is 1/2, so if this is 1 and -1, 1/2 is about right here, and -1/2 is about right there. I'm a little off on that. And we have to remember to do a vertical flip of our cosine graphs. So our cosine graph is normally the top of a hill, bottom of a valley, top of a hill. I need to flip that. So I need to start at the bottom, go through the midline, then be at the top, back through the midline, and back down. So I end up looking like this. It is a flipped cosine graph with an amplitude of 1/2 and a period of pi over 2. Occasionally you get some weird answers when you calculate your period, and so I just want to practice these with you because we're not going to actually put a graph with them. We're just going to label this x-axis just to get you used to some of these fractions, because I know it's been probably since elementary school since you've worked with them as much as you are right now. So always put that on the end, and then we'll have our middle point, our quarter point, and our third quarter point. And then you have to think, what's halfway between 0 and 2 pi over 3? Well, if this is 2 pi over 3, then halfway is 1 pi over 3. And then what is halfway between 0 and pi over 3? Well, if you can't figure that out, you can just multiply the denominator by 2. Halfway between 0 and pi over 3 would be pi over 6. Because what you're really doing is saying half of meaning multiply pi over 3. And so if you multiply straight across, you get pi over 6. And then that is what you're counting by, 1/6. So 1/6, 2/6, we already have there and it's reduced. Then I have 3/6, but 3/6 reduces and you get 1/2, or pi over 2 in this case. So that's how we label that. Now I'm going to do one that's really weird, because if you can do the weird ones, you can do any of them. So 8 pi over 5, that would be our end. What would be the middle? Well, halfway between 0 and 8 is 4, so this will be 4 pi over 5. And then halfway between 0 and 4 is 2, so this is 2 pi over 5. And you have 2, 4, this one will be 6 pi over 5. So sometimes you just have to work on thinking in fractions. Alright, the next part of our notes we're going to be talking about horizontal or phase shifts. And that's shifting this graph left and right. And I mentioned that cosine is just a shift of the sine graph, and you could write it using this knowledge as a shift. Now, how we're going to calculate this is this formula right here. This is another one that you want to write down. Make sure you know you have somewhere important. Horizontal shift is negative c over k. Your k is still the number in front of your theta. So that's not changing, and you will still calculate your period using that k. But you know you have a horizontal shift when you have a minus or a plus right here with this c. And so we will use the negative of that value, whatever that value is, over k to figure out our shift. And just like when you are shifting your normal functions, if you have a minus here, it's going to go right. If you have a plus here, it's going to go left. So you can tell that before you do your math. Now, when you do your math, the positives go positive and the negative go negative. But looking at the formula, it's the opposite, just like when we do other functions. Okay, so I'm going to do an example here. I'm going to ease into the changes. This one, the only change is going to be your horizontal shift, because I don't have a number other than an understood 1 in front of the x, and I'm not changing the amplitude. So I'm just changing so that we have a horizontal shift here, so you can see what happens. So our horizontal shift, I can tell just by this, because this is a minus in the equation, that we're going to be moving right. When you figure this out, I said do negative c. Well, c is the negative pi over 2 over k, and a k is 1 because it's understood 1. And so you get a positive pi over 2. When you get the positive here, that means right as well. If you get a negative here, it means left. But in the formula, again, in the equation, it's the opposite. So, no period change means we're going to 2 pi. So everything is your standard labels. And our y-axis, we didn't have an amplitude change, so we're going to 1 and negative 1. And now, since we're going to be shifting right pi over 2, I'm going to have to add some to the end of this so that I can shift my graph right. Because before I shift it, it's going to look like this. But I do need to shift it right, because that's what they're asking us to do. Well, how much is pi over 2? If you look at your scale, your pi over 2 is one of our blocks, because from 0 to this tick mark is pi over 2. So I'm going to be shifting right one block. What's the label for that block? Let's go back and count. 1 half, 2 halves, 3 halves, 4 halves. This is 5 halves. So you need to come up with that label as well. And then your whole graph is going to shift right one block. So the point that was at 0 is now going to be at pi over 2. The point that was at pi over 2 is now going to be at pi. The point that was at pi is now going to be at 3 pi over 2. The point that was at 3 pi over 2 is going to be at 2 pi. And the point that was at 2 pi is going to be at 5 pi over 2. So your whole graph has shifted right one block, which is pi over 2 units, the way we have it labeled. Okay, I have 2 more examples, and I'm going to start looking at this one. This cosine graph is going to be flipped, but when I see the plus here, I know it's going to move left, and so that means that I need to change the way that I have this set up a little bit so that I can fit everything on here. I'm not sure how much I'm going to need. So if I'm moving left, I need to be past that y-axis. Okay, so let's write down our changes. The negative out front says that we have a vertical flip. I don't have an amplitude change because there's an understood 1. I don't have a period change because there's an understood 1. But I should be moving left because that's a plus. And we can figure out that horizontal shift by doing negative c, so c this time is a positive pi, over k, which is an understood 1. So we're going to be negative pi here means I'm going left pi. Okay, so if you need to write down left or right, write it down. You could write it down from noticing that was a plus or from getting a minus here. So I'm going to start again with our normal graph and say that this is 2 pi, and I have pi over 2 and 3 pi over 2 because our period did not change and our amplitude did not change, so negative 1 to 1, and I'm going to have 0 here. So normally a cosine graph would look like this, but if I'm going to move left pi, I need to put some marks over here so that they will fit. How much is pi? So if I find pi right here, that is from 0, that is 2 blocks. So I need to go 2 blocks left, and that would be your negative pi. So this first block would obviously be the negative of pi over 2. And then once I have those labeled, I'm going to do this one in red, I'm going to move this graph over, so where it starts there. So it's going to start, go through, hit the bottom, go through, and then hit the top. And so there is our new cosine graph. Now, obviously with these examples, I am only drawing one period, but please do not forget that the cosine graph and the sine graph continue on forever. So just because I've moved this part of the graph over doesn't mean this doesn't keep going. This actually does keep going in both directions forever. We're just looking at specific things that are changing, and you would be able to pick something like this out, hopefully, of a multiple choice question or create this on your own. Okay, last example I'm going to do has a period change and a horizontal shift. This x over 2 you have to view as 1/2 x, which means our k is 1/2. And so our period would be 2 pi over 1/2, which is 4 pi. And then our horizontal shift, negative c over k, well, this is already negative, so I have a negative pi over 4 over our k, which is 1/2. I have to flip and multiply. 2 negatives will make a positive, and if I do pi over 4 times 2 over 1, I'm going to get pi over 2. So our new period is pi over 2, and I'm going to be shifting to the right because this minus here. Excuse me, not our period pi over 2, our horizontal shift is pi over 2 to the right. Our period is 4 pi. This one's going to be a little weird to label, so I'm going to say that our 4 pi is here, so I have a little bit of room. I have 2 pi here, 1 pi, and 3 pi, so that our normal labels are in place. I didn't change the amplitude, although I could have put a number in here, and that would have been fine. It would just change our y-axis a little bit with our labeling. So 1 and negative 1 still. And again, this is a sine graph, so before the horizontal shift, it would look like this. But I'm going to shift it over pi over 2. Well, how much is pi over 2? I don't have pi over 2 labeled here, so you have to remember it's halfway between 0 and pi. So pi over 2 is actually right there, and I'm going to come in red and label those. So this is pi over 2. I'm going to need all these marks at the halfway points if that's how much I'm going to shift over. So I have 1 over 2, 2 over 2, 3 over 2, 4 over 2, 5 over 2, 6 over 2, 7 over 2, 8 over 2, 9 over 2. So if we're going to move right 1 pi over 2, I should end on that 9 pi over 2. Okay, now I'm going to move that whole graph over to the right, pi over 2. So the point that was on 0 is now going to be on pi over 2. The point that was on pi is going to move over to 3 pi over 2. The point that was on 2 pi is going to move to 5 pi over 2. The point was at 3 pi is going to be at 7 pi over 2. And the point that was at 4 pi is going to be at 9 pi over 2. So everything is moved over a half a block from normal. And we are doing the sine graph. So that's how that one ends up, and that's probably as complicated as you're going to see it. You might have an amplitude change with that, and if you really wanted to get complicated, you could put a vertical shift on there. And before I let you go, I just want to point out the mistake I made and just realized I forgot to do the vertical flip on 6, so come in, I'm going to do it in black. We did move the cosine graph, I just didn't flip it, so it should be the flip of what I had. And I apologize for that. I told you that was the worst mistake I tend to make with these things, is forgetting to flip. So you catch me in my mistake, but I caught it before I totally finished the video. So there is our flip of the cosine graph. Please fix it if you wrote it down incorrectly in your notes. And that concludes this lesson.